Hello, and welcome back to Training with Trisonius. You guessed it, I am Trisonius. Today, we're going to focus on arrays. What are arrays? Well, it's a fixed size sequential collection of elements of the same type. I'll explain more, and it'll make more sense as we move forward. Let's go ahead and look at what we're going to learn today. So we're going to learn about an array and the actual definition of that array. We're going to learn how to declare an array and then how to initialize an array. Assigning and accessing values within an array. What are multidimensional arrays? And the array class. Now we're getting very close to moving into object-oriented programming. And so we'll be moving there very, very soon, probably one or two more lessons. But it is important that we understand arrays. So with that, let's go ahead and get started. Oh, by the way, in case you haven't noticed, and I'm sure you have, I received some feedback that the blue background was a little bit too light, and people were having trouble seeing the text on the screen. So in response to that, I've tried a different background color. I hope this is okay. If it's okay, great. If it's not, drop me a line below the video, just a comment, and let me know, and we'll flip to another format, and we'll eventually find something that works best for everyone. Okay. So the definition of an array. So an array stores a fixed size sequential collection of elements of the same type. So you can have an array of integers, an array of strings, an array of bytes, and you can have, it's a collection, if you will. Now, it's hard for me to use that word because that means something else that we'll learn about later, but right now we'll use that term. It's a collection of like types. So an array is used to store a collection of data. But it's often more useful to think of an array as a collection of variables of the same type stored as contiguous memory locations. So let's say that you had you were writing a program and you were going to keep track of 30 students in a class, and you needed to keep track of each student's grade. Well, you could declare 30 different variables, or you could declare one array and it have 30 elements to it, and each one of those elements could store a score representing what an individual student has scored. So here in the text it says, instead of declaring individual variables such as number 0, number 1, all the way to number 99, you declare one array variable such as numbers, and you use numbers, open bracket 0, close bracket, numbers, open bracket 1, close bracket, and so on to represent individual variables. A specific element in an array is accessed by a numeric index. Now that index begins at 0. So the first element in an array is at index 0. The second element of an array is index 1, and so on. All arrays consist of contiguous memory locations. The lowest address corresponds to the first element, and the highest address to the last element. So if you look at the picture here at the bottom of the screen, you'll see that we have an array called numbers. Numbers with an index of 0 is the first element, all the way to the last element. And in memory, within RAM, all these values are stored right next to one another. So it's easy and fast to access them. Okay. So that's great. We understand what an array is now. That's good. It's not that difficult. You've been dealing with variables, and it's just an easier way to manipulate and use variables of the same type if you need multiple variables of that type. So you declare an array in a similar way to how you declare a normal variable. So the syntax to declare an array is you define the data type. The difference is between this and a regular variable is once you define the data type, you put an open square bracket and then a closed square bracket space, and then you give the name of the variable that represents the array of data types. So the data type itself is used to specify the type of element in the area. So example, an integer, open bracket, close bracket, would be an array of integers. Double, open bracket, close bracket, an array of doubles. And then same thing with string or any other type for that matter. The open bracket, close bracket specifies the size. So inside of these brackets, it's also referred to as the rank. And inside of these brackets, you can place a whole number. And that whole number represents the number of elements that the array will contain. So for example, if you have an integer, open bracket 4, close bracket, that's going to be an array of integers, and there'll be 4 integers stored in that array. But remember, it begins at 0. So element 0 is the first element. So you'd have element 0, element 1, element 2, and element 3. Okay, the array name obviously specifies the name of the array variable. So at the time that you declare an array, you can initialize that array. Declaring an array does not initialize it in memory. All it does is tell the compiler, tells .NET Framework, that you're about to use an array, and so you've associated a type with a variable name, but you've not pushed it into memory yet. So once an array is initialized, then the space is created for it within memory, and you can assign values to the array. An array is a reference type, so you need to use the new keyword to create an instance of an array. Below is an example of declaring and initializing an array. So here in the bottom here of your screen, let's zoom into that a little bit. There, you can see we have an array of integers, and we have named that array. The array, we've given it a variable name of student scores equals new integer array, open bracket 10. So it's in this way that we're telling the computer that, okay, we want an array of integers. We're going to name it student scores. Now go and create a new memory space to hold 10 integers as part of an array and assign that space to the student scores variable. And so remember, equals is an assignment operator. New simply tells the framework that you need to create a new memory location for a reference type. And so in this case, we're saying go create a new memory location for a reference type of type integer, which is an array with 10 elements. And that would be an array having indexes of 0 to 9. Okay, I know that's a lot to take in, but stick with me. We'll get through this, and hopefully it'll make a little bit more sense once you start to see how easy it is to use these. So assigning and accessing values. So you can assign values to an individual array element by using the index number. So again, let's go back to our example, where we declare an array of type integer. We name it student scores. We assign to it a new memory location holding 10 instances of integers in contiguous memory as part of this array. Now, we can put the score 88 and assign it to student scores element 0 by typing in student scores open bracket 0 close bracket equals 88. What we're doing here is we're basically saying, okay, let's go to the first element within the student scores array. Let's assign the value of 88 to that element. So now, each individual element, think of it as its own integer variable. You just don't have a different variable name. You have one variable name called student scores, but instead of having to keep up with 10 different variable names of type integer, we only have one variable name, and we can reference each integer by an index. And so in this case, we're going to assign the value of 88 to the first element of the array. Now, at the time that you declare a variable, you can also assign values directly to the array without having to define the array size or rank. Now, you can do that, and here's the example of how you do that. And this is if you happen to know what the values are that you want in the array, you can declare your array of type integer, open bracket, close bracket. We'll still call it student scores. And we will assign to it 4 numeric values, right? Now, these values need to be something that's compliant with an integer type, because remember, C# is type safe. And so in this case, we have 88, 67, 94, and 72. Those are 4 values that are going to be placed into the student scores. So at index 0, the first element of the array will hold the value of 88. The second element will hold the value of 67, the third 94, and the fourth 72. So it's just a way of, at the time that you declare your variable, you can initialize it this way. And you don't have to set the size of the variable, the array. It'll figure it out based on the number of values you're passing in. Now, you can also create and initialize an array and assign values at the same time of declaration by defining the size or rank of the array. So the next example is exactly that. So you have a variable of type integer. It's of type array because we see the open bracket, close bracket. We've named it student scores. We want to reserve memory for 4 integer elements within this array, and then initialize those 4 with the values that are between the curly brackets. So in this case, we've defined the size of the array and provided the values at the time of initialization. At the time of declaration, we've initialized the array with these 4 values. All right. So those are 3 different examples of how you can create an array within code. Now, an element is accessed by indexing the array variable name. So all you do is place the index of the element within the square brackets after the name of the array. For instance, here at the very bottom of your screen, you can see that we've declared an array of type integer called student scores. It has 4 elements. We've reserved the memory for that by using the new integer open bracket 4 close bracket. And then we've initialized it with 4 values, 88, 67, 94, and 72. And then we declare another variable called a type integer. We'll call it John's score. Maybe we have a student named John. And we want to grab the score out of student scores and assign it to this. So we grab the student scores open bracket index 2 and assign it to John's score. Index 2 would represent the 3rd element, because remember, it starts at 0. So the first element would have a value of 88. The second value or element would have a value of 67. We're going to take the value of 94 and assign it to John's score. I hope this makes sense. So it's real simple. You can add or assign a value to the element of an array by using its index. And you can retrieve the value from an array by using its index. Okay, continue to move on. So here's an example of accessing an array. This is where the power really comes in. So we'll store individual student scores in an array of type integer. One array will allow us to store the test scores for 6 students. Okay? Then we can access each element of the array using a for loop. So you can't really do this with 6 different variables, but you can do this with a single array. So let's look here. And you can feel free to type this code in and test it, and it'll run. So in our example here, we declare an array of type integer. We call it student scores. And then we assign to it a new memory location designed to hold an array of integers having 6 elements. Now we also go ahead and populate or initialize that array with values. And so we do that with our open squirrely bracket and or curly brace, and then we have the values 88, 72, 92, 67, 89, 100, close curly brace, semicolon. So that one line says, let's declare the variable, let's declare the array variable. We're going to call it student scores. It's going to hold 6 values of type integer. And let's go ahead and put the values into it all at the same time. Now we know that there are 6 elements in this array. What we can do is we can loop through the entire array and print out its values. So we can create a for loop. Remember our class over loops? We had a lesson over our loops. So we're going to use a for loop here. And we're going to type in for. And we need an initialization value. So we're going to declare an integer named count and assign it an initial value of 0. Now, as long as count is less than student scores.length, and by the way, .length gets the length of all the elements in an array. So what we're saying is, as long as count is less than the total number of elements in the array, then continue to loop and then increase the counter by 1 each time you do. So then we're going to type in console.writeLine. We're going to print out to the screen element, open bracket, and we're going to put a substitution token there, 0, close bracket, equals substitution token 1. And then the first substitution token, we will put the value of count, and the second substitution token will contain the value of student scores, open bracket, count, close bracket. So remember, count is going to start off at 0. So the very first time that we come through here, we're going to write to the screen element, open bracket, 0, because count equals 0. Close bracket equals, and then we're going to get the value from student scores in element 0 or index 0, right, which will be the first element of the array, which will be 88. So the above code will produce the values, that you see. It'll produce the result you see shown below if you were to run that code. Okay, and remember, if you do not remember substitution tokens or you don't remember the for loop, I encourage you to go back and look at the previous lessons because we've learned all of these things already. You may just need a refresher. Okay, so arrays are great because they allow us to hold information that they of the same type. But arrays do more than that. There are something called multidimensional arrays. So what if we wanted to represent a grid, a table, if you will, that had columns and rows? We could do that by having 2 dimensions to our array. One dimension would represent a row, and the other dimension would represent a column. So the simplest form of the multidimensional array is the 2-dimensional array. Now there are also 3-dimensional arrays and 4-dimensional arrays. The concept remains the same. We're just going to go over 2-dimensional arrays right now. But a two-dimensional array represents a two-dimensional grid having columns and rows. A two-dimensional array can be thought of as a table which has X number of rows and Y number of columns. Every element is identified by using two indices in the form of the name of the array, open bracket, X, Y, close bracket. And so what that does is if you want a value, you can give it the name of the array, pass an index for X, and pass an index for Y. So let's say you passed X0, Y0. Well, that would give you the value that was stored in column 0, row 0. But if you passed X0, Y1, you would get the value stored in if you passed X0, Y1, you would get the value stored in row 0, column 1. All right, so I hope that makes sense. Initializing a two-dimensional array and accessing the values of the fourth element within the third row. All right, so let's give you an example of this. So in the bottom left-hand corner of your screen, you see a code snippet. Here we are declaring a two-dimensional array of type integer. So we type in integer, open bracket, comma. What the comma does is it simply says, okay, there's going to be two values. So two dimensions, if you will, because you separate each one of your dimensions with a comma. So open bracket, comma, close bracket. We're going to name our variable table. We're going to assign to it the new memory location for a reference variable of type integer array, and it's going to have 3 rows and 4 columns. Okay, so the first dimension will have 3 elements, the second dimension will have 4. And then we're going to initialize this by assigning the values to that array as well. And so you'll see that there's 3 rows. The first row, we're going to give these 4 values. The second row, the next 4 values. And the third row, we'll give the values 8, 9, 10, and 11. Now, if we wanted to access a cell in this table, right? We wanted to access a certain set of elements. We have to tell it what dimensions. So since this is a two-dimensional array, we have to tell it where in the table we want to get that value from. So we can just declare a variable, call it table cell value, and assign to it the value that's in table, open bracket, the third row, the 4th element. So the third row, remember, it starts at 0. So table 0, 1, 2. That gives us the third row. And then the third or 4th value, the 4th element within the third row. We want the value from that location. And this is how you would get that. Okay, again, it may seem a little bit confusing, but once you see it in action, it's really not. It takes a little bit of practice like anything else, but I'm certain that you'll get it. Okay, let's talk about the array class a little bit. So the array is, in and of itself, a class. And as such, it has its own methods, and it has its own variables. So there are several exposed data elements and methods within the array class that are already written for us. And they're designed to make working with arrays easier and more effective. Now, you can go to Microsoft's website and you can type in, or do a search on C# and array and learn a lot more than what I'm going to teach you here in this particular lesson. But the most popular methods, at least from my perspective, I've listed below. So length. So if we type in the name of the array dot length, it gets a 32-bit integer representing the total number of elements in all dimensions of the array. So the total number of elements is what dot length gives you. We used that in an earlier example when we were looping through a one-dimensional array. Now rank. Rank gets a 32-bit integer representing the total number of dimensions within the array. So length gives you the total number of elements. Rank will give you the total number of dimensions. So that's just, you type in the name of your array dot rank. Now, you can also type in array get length. So array dot get length. It returns a 32-bit integer representing the number of elements in a specified dimension. So when you call get length, you pass to it the dimension that you want it to reference, and then it will return to you the number of elements in that dimension. Get upper bounds will return the upper bound of the specified dimension in the array. So array name dot get upper bound, open parenthesis, pass it the numeric value of the dimension, close parenthesis, will return to you an integer with the upper bound specifying the dimensions in the array. Index of. It searches the array and returns the index number of the first matching object. So let's say you have an array of strings. You could type in array.indexOf, pass in your array, comma, a string value, and it would return to you the first index number matching that particular string. You could also type in array.reverse and then pass in your array in between the parentheses, and it would reverse the sequence of the elements in one dimension of the array. And finally, you can also use it to sort the elements in one dimension of an array using the dot sort method. I put in here that it uses comparable of each object. We'll learn more about that later. So don't let that confuse you, but just know that you can sort your arrays. Okay, let's jump into Visual Studio. We're going to go create a new console application. So let's click on Console Application. We're going to give this the name of Array Lesson. And go ahead and click OK. We'll let that go ahead and practice. Pull that up. Sorry, I was reading the project names. Okay, so we have our application here, our console application with its default namespaces, and then we've named this particular solution Array Lesson. This project is named Array Lesson, and therefore the namespace is defaulted to the same name as the project, which is Array Lesson. Okay, what we're going to do is I'm going to give you an example of how to declare a new array of strings. Okay, so what we're going to do is we're going to go create a new method, just because I want to tie some things together. So let's just make this static void assign name. So we're going to create a new method that's going to be responsible for assigning names to an array. Okay, so let's go and declare, for the purposes of this project, a static variable, which will be of type array. So let's make an array of strings. So static string, open bracket, close bracket, that defines that it's going to be a string of array. I mean, an array of strings. And then we're going to name this array names. How's that? And then we will make it equal to new string. And let's say we want 6 names in here. Semicolon. There we go. So we've now declared a new array of type string. It'll hold 6 string values, and we've referenced the name of this array as names. So down here, what I want to do is assign some values to names. So for the first element in the array, so names 0, remember it starts at 0. Let's put the name, let's use female names, if that's okay. Let's use, Susan, Betty, Shelley, names 3. Oh, this is the 4th name because it's offset by 1. Lisa, names 4. Barbara, and the last name, let's make it, I don't know, Leslie. Okay, there we go. I should have put Christy as one of the names in here since she's my wife, but I did not. So I'll probably hear about that later. Anyway, we've assigned the female names to our array, and we said we were going to have 6 names or 6 strings in this array, and we have stored 6 strings in this array. We named the array names, and so we want to always name our variables in a manner that represents the values they'll be holding, and in this case they are holding names. So that's great. So the first thing we want to do inside of our void main is call the assign names method. So let's go ahead and do that. Assign names. So there we go. By calling the assign names method, it forces the application flow control to jump down to assign names. It executes each of these lines of code, and then it returns. So after assign names is called, we should then have the names, the 6 female names in our array that we've declared as names. Now let's say we want to randomly choose a name. How about that? All right. Well, what we're going to do is we're going to declare a static object up here that's going to of type random. And what random does is it's a class that's used to generate random numbers. So we're going to static random, we'll just name this variable rand. And because it's a reference type, we need to load a new instance of it into memory. So we use the new keyword random. All right, there we go. So now we've declared a new variable by the name of rand. It's of type random. It's in memory and it's available for us to use. So what I want to do is I want to generate an integer. So between the values of 0 and 5. So what I'm going to do is I'm going to declare an integer, and I'm going to call it generated number. And we're going to make it equal to rand.next, open parenthesis. And what this does, we're going to use the rand object to generate the next pseudo-random number in the sequence of numbers. So what we're going to do is we have a method called next that allows us to do that. And if we click on this down arrow, we can see that we can returns a random integer that is within a specified range. So min value is inclusive of the lower bounds. Max value represents the total number of values, not the upper range. So what we want to generate a number between 0 and 5. But the number 0, 1, 2, 3, 4, 5, right? That is 6 numbers that can be generated. So the upper bounds represents the total number of values that we want to generate. So in this case, because rand.next will generate a number from 0 to 5, because 0 is a value, and then it will generate 5 other values as well that are below 6. Okay. So now that we have our generated number, we can write to the screen console.writeLine, open parenthesis, then the random name is, and we'll use a substitution token, and then we'll just put comma and the value. And so what we want to do is we want to use the names array, and then our index is going to be the generated number, right? Because the generated number should be between, and it helps if I actually spell that correctly, generated. This is why I'm a programmer and not an English professor. Okay, there we go. So what that should do, believe it or not, is that should write out a random name from our array. Because what's going to happen is we're going to generate a number from 0 to 5. Then we're going to go to the array, and we're going to say, okay, look at the names array at this index. Well, generated number will be between 0 and 5. And so if it generates a random number of 4, it's going to pull Barbara, because Barbara is an element 4 in names. Does that make sense? All right, and then so let's go ahead and I'll put a console.writeLine as a blank line before and after this, just to so the screen's not too cluttered. All right, so let's go to debug. Start without debugging. Let's run this, and it should display a random name. The random name is Betty. That's fantastic. Okay, let's run it again. Debug, start without debugging. The random name is Susan. Let's run it again. Start without debugging. The random name is Shelley. Fantastic. So it's generating a number, and then we're using the number that was generated as the index to reference the certain element of the names array and pull its value out. And then that value gets put in the place of this substitution token. Remember about substitution tokens, you can look at strings that, we did a lesson over strings, a deeper dive into strings earlier in the overall course. So I would encourage you to go back and look at that. Okay, so there's one example of how we can use an array. We can also use an array to store items. So let's say we wanted to represent a backpack in our game. We could do that fairly easily. Here, let me give you an example. So I'm going to go ahead and erase all of this code, okay? So let me just put it right here. I'll leave it all on the screen there for you for just a second in case you want to screenshot that to come back to, or you can always, just come back and watch the video again and pause it here. I'll give you a second. Okay, all right, I'm going to go ahead and erase this now. So let's go ahead and erase our variables and our static void back in place. We'll erase all that code, and then we'll erase this entire method. Okay, so let's say that we want, we'll just do all this in, well, let's say we want a backpack. So let's go ahead and declare static, and let's say we'll just hold the names of the names of items. So static string, I want a string array. I'm going to call it backpack. Okay, and we're going to make it equal to new string. Let's say we can hold up 10 items in our backpack. Okay, there we go. So we now have an array called backpack. It's an array of strings, and it will hold up to 10 strings. Fantastic. So let's go add a new method. Static void add item to backpack. Okay, we'll just do that right there. And what we're going to do is that in here, we're going to loop through our backpack and make sure and see if we find an empty space, right? And if we find an empty space, then we'll be able to add something to our backpack. And if we don't, then we'll let them know that we didn't. So why don't we make this a bool? Okay, and we'll declare a variable type bool. Remember, a bool is true or false. So we're going to use this bool to indicate whether or not we were successfully able to add an item to our backpack. So if our backpack was full, then obviously it's going to return a false. And so we'll just call this variable successful. And we want it to return successful, and then we'll set successful as we move forward. So let's go ahead and initially set successful as false. How about that? So we're going to initialize our Boolean variable to say, okay, you know what? We weren't able to add it. Now we're going to need to pass into this method a string representing the name of the item that we want to add to our backpack. Does that make sense? So the first thing we're going to do is we're going to loop through our array, our backpack, to see if we can find an empty spot. So we're going to do that using a for loop. So for int count equals 0. Remember for loops? If not, go back and watch the lesson over loops. For int count equals 0. As long as count is less than backpack dot length. Since we only have one dimension, this gives us the number of elements, total elements. So it'll give us 10. So as long as our count is less than 10, then it'll keep going. But as soon as our count's no longer less than the length of that array, then obviously we'll break out the for loop. And so this is our conditional operand. All right, so but if count is less, then let's take count and add 1 to it. All righty, and let's put our brackets here. So what we're going to do is we're just going to check. We're going to use an if statement inside of our for loop, and we're going to check to see if backpack count. So remember, the first time it loops through, count will have a value of 0. So we're checking to see if backpack element 0 equals string dot empty. Okay, it's just an easy way of checking to see if it's an empty string. If it does, if it is empty, then what we're going to do is we're going to set our backpack backpack count equal to item. In other words, we found an empty one, so let's take the item that we passed in and assign it to that location within our backpack. Now that we've found a place for it, we can set successful equal to true, so that it's going to return successful. And then we want to stop it from looping anymore, because we already found an empty one. Remember how you stop a loop? Yep, you can just use break, and that will stop the for loop, because we found an empty spot. No reason to keep looping through our backpack to find an empty spot. We already found one. And then we can return successful. Okay, does that make sense? So up here, we're going to add some items to our backpack. Okay, so if add item to backpack, open parenthesis, we need to pass an item to it. Let's pass apple. So we're going to pass an apple. As long as that's true, we will be able to actually, you know what, down here, we will also, we'll just, you know what, I don't even need to set this as a Boolean. Let's just take that out. Let's simplify this. Okay, sorry for switching that up on you there, but let's just simplify this. Let's just put everything inside of this one method right now, and let's just make this a void. And so if we find an empty spot, let's go ahead and tell right to the screen that we found an empty spot and that we're adding an item to the backpack. Okay, so here we go. So brother, you know what? Actually, I do need that Boolean back, but I don't need to return it. So I'll just call this found place equals false. All right, sorry. So, sorry, I do need a Boolean there. So when we find an empty place, we're going to store the item in it. We're going to set found place equals true. Okay. And then we'll break out of the for loop. Now we can come down here and we can put if found place equals true, console.writeLine, open parenthesis, the whatever the item is, added to your backpack. Awesome. Else there is no room for the item in your backpack. Okay, there we go. So we'll let it control its own true or false to determine whether or not it found it. And we'll keep that within this method rather than returning it back. Okay, so let's go ahead and move up here. And we'll put an apple into our backpack. You ready? So let's just type in add item to backpack, open parenthesis, apple. Add item to backpack, open parenthesis, pear. add item to backpack, open parenthesis, knife. Maybe this individual is going camping. Add item to backpack. Rope. We need some rope. Add item to backpack. Tent. Okay. So we've added all these items to our backpack. Now let's go add another method to display what's in our backpack. Okay. So let's come down here to the bottom of this, and we'll create static void display backpack. Okay. And what we want to do is just loop through. So let's create another for loop. For int count equals 0, count less than backpack dot length count plus plus, and let's make sure that it's not blank. So if backpack count not equal string.empty, then we can do console.writeLine item colon space plus backpack count. There we go. So we're going to add these items to our backpack, and then let's just call display backpack. Let's go test this out. Hope you guys are with me. Debug, start without debugging. And oh wow, I only put the, it says there is no room for the apple in your backpack. Wow. And so then it lists out the items. That's not at all what I was expecting. Why did it do that? And so let's look and make sure that backpack count equals null. How about we change that? So that means it hasn't really been initialized yet. Let's try that. Ready? And then down here, we'll check to make sure that if it's not equal to null, then we'll grab it. Let's try that. Debug, start without debugging. And there we go. Apple was added to your backpack. Pear was added to your backpack. Knife was added to your backpack. Rope, tent, and then it lists out the items. Apple, pear, knife, rope, tent. Very good. So if we were to copy all of these, paste them again, that would give us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now in theory, now what we'll do is we'll put a console.writeLine here, then console.writeLine items in backpack. Okay. So now let's run this again. In theory, all those items should fit. We should end up with 2 of each thing. So debug, start without debugging. And we got everything was added to our backpack, and then we can see all the items in our backpack, so we know that they're there. Excellent. Now, if we tried to add item to backpack, gold watch, we should be out of room. Let's see what it says. So we added everything, but it says there is no room for the gold watch in your backpack. And then when we display our backpack, sure enough, no gold watch is in there. Okay. I hope that makes sense, guys. I hope you learned something. Until next time, we'll do it again. I encourage you to practice. Create some programs using arrays. We'll be getting back to building our application soon. If you wanted to, you could go back to your application that we started and create an inventory, a backpack at least to store some items. Anyway, let's go ahead and move on to our wrap up and do a review of what it is that we've learned. Okay, so what did we learn today? Well, we learned that an array stores a fixed size sequential collection of elements of the same type. So fixed size of integers, right? And you could have a number of elements in that array, or strings, or any type. An array is used to store a collection of data, but it's often more useful to think of an array as a collection of variables of the same type stored at contiguous memory locations. Okay, the syntax to declare an array is as follows. You use the data type, open bracket, close bracket, and then the array name is your variable name. Remember, data type is used to specify the type of the elements in the array. Open bracket, close bracket specifies the size, also referred to as the rank of the array. And array name specifies the name of the array variable. Remember, you can assign values to individual array elements by using the index number. I know the text says but using, that's a typo, sorry. You can assign values to individual array elements by using the index number. So again, in our example here, we have declared an array of integers. We call it student scores. We assign to it a new memory location holding 10 integers as part of the array. And then we assign to the very first element the value 88. And then in our second example, we're declaring an array called student scores that will hold 4 elements of type integer. And then we're initializing that array with 4 values at the point in time that we did the declaration. It is important to note that you can only initialize a variable in this way at the time of declaration. Otherwise, you have to assign values using the method that we see on the left-hand side of the screen here, where student scores element 0 or index 0 equals 88. So arrays are powerful collections of data that enable looping to access values by index. We saw an example of that. And then get upper bounds returns the upper bounds of the specified dimension in the array. You'll use that quite a bit. Okay, I hope that you learned a lot. I know that we still have not really returned to the game yet, but we will be returning to the game development very soon. There have been so many things that we needed to learn that it required us to kind of go off on a tangent. But we'll be taking all of these things we've learned, combining them, and moving back to building our game very soon. Okay, guys, thank you so much. I appreciate your time. I hope you learned something, like always. And until next time, this is Trisonius, signing off.